So we discussed in the previous video how out of the thousands of nuclides existing at present, only about 250 are stable and the rest are unstable. So they're radioactive. And those radioactive nuclides are either existing naturally or prepared synthetically. So along with naturally occurring radioactive species are those that are synthetically radioactive. And radioactivity of this type is called artificial radioactivity. Now to date, there are more than 1,500 radioactive isotopes prepared in the laboratory this way. And the process of preparing a synthetic radioisotope is called a bombardment reaction. It's called bombardment because a stable nucleus is converted to one that is radioactive by bombarding it with a particle. So the particle could be a neutron or an alpha particle, a beta particle, or it could be another nucleus. Now, in the bombardment process, the particle that is to bombard the nucleus must move very fast to penetrate the nucleus. Kaya i-overcome ba ito niyang mga forces existing, no? From outside, it has to go straight into the nucleus. So, muna i-bombard siya. So, they have to be accelerated so that they would overcome the electrostatic repulsion between them and the target nucleus. There, napay strong force, no? So, kinahanglan masud siya dito. The instrument used in the process is called a particle accelerator, popularly known as atom smashers, where small alternating voltages are used to increase the energy of the particle. It has to move high energy para move siya very fast para mahit ang target. So nuclear reactions induced this way are called nuclear transmutations. The substance is transmuted into another configuration. The first man-made nucleus prepared in the laboratory was prepared in the laboratory of Ernest Rutherford in 1919. So he bombarded one type of nuclei with other nuclei or with neutrons. So what he did, he bombarded nitrogen atoms with high-speed alpha particles from a natural radioactive isotope of radium and observed protons resulting from the reaction. So from nitrogen-14, bombarded it with high-speed alpha particles, producing stable oxygen-17 and a proton. So ang product sa bombardment niya nga reaction kay stable sila. So no need to find stability anymore. So no need to undergo decay anymore. So no further changes occur. But even if ang ihang na-produce diri kay stable nga mga particles, ang process nga iyang gibuhat led many scientists to synthesize hundreds of radioisotopes in the laboratory. Ang iyang process nga gibuhat. So, what Rutherford was able to produce kay stable, so ang first nga radioactive isotope nga made in the laboratory using his process were prepared in 1934 by Irene Curie and her husband Frederick Joliot. So, what they did, they bombarded certain stable isotopes with high energy particles, alpha particles. So, ang aluminum, stable, aluminum-27, gibombard og alpha particle ni produce og phosphorus-30 plus a neutron. So, the phosphorus-30 is a radioactive isotope and it will still undergo decay. So, mo decay siya by positron emission, producing silicon-28. So, in many transmutation reactions, the new isotope formed is still radioactive. And an important application of these reactions is the preparation of the so-called transuranium elements. So, you can find that in your periodic table kung asa nadapita ang transuranium nga elements. So, example, ani nila, neptunium and plutonium are transuranium elements. They are produced in 1940 by bombarding uranium-238 with neutrons. Okay? So, this is the process of producing neptunium and plutonium. So, several steps. Curium-242 is formed when plutonium-239 target is bombarded with accelerated alpha particles. So, as you can see, there is also a neutron produced in the process. In 1996, a team of European scientists, so medyo bago pa siya, based in Germany, synthesized element 112 by bombarding a lead target continuously for, imagine that, 3 weeks with a beam of zinc atoms. So lead bombarded with zinc, produced, what do you think is this element? Element 112. What does CN stand for? I want you to look at that. Search kung unsa na siya. And a neutron. So what are the applications of radioactivity? So we think that radioactivity is just harmful, no? Bad ang iyahang effect. But actually, there are many uses of radioactivity. So radioactive isotopes are commonly used in cancer therapy, usually to eliminate any malignant cells left after surgery. So, di ba, kung kanang radiation, di ba, kung undergo radiation kung na-cancer, kung dili na jud madala sa chemo nga sessions, so undergo radiation. So, cobalt-60 is most often used. Gamma rays from this source are focused at the small areas where cancer is suspected. So, paagi diri, na diri ang target, muhit siya, no? So, this is the source, so muhit siya dito sa tumor. And it can eliminate the malignant cells. Another use of radioactive nga substance, so this is a radioactive iodine, which is also used to treat cancer, no? So, when a patient is suffering from cancer of the thyroid, drinks a solution of sodium iodide, wherein the iodine here, ions, kay radioactive. So, iodine 131 ug iodine 123. It moves preferentially. So, isn't amazing? Move lang siya to the thyroid gland. And there, it will destroy the malignant cells without affecting the rest of the body. So, amazing how these things work. So, these are examples of different isotopes which are used in diagnostic purposes. So we have here carbon-11 for brain scan, sodium-24 for circulatory disorders, phosphorus-32 for detection of eye tumors, iron-59 for anemia, gallium-67 for the scan for lung tumors, selenium, no? So we have here for pancreas, for imaging of the brain, for lungs, and for heart diseases. So there are still a lot more of these. So they're actually very useful in the area of medicine. And then we have americium-241, which is used in smoke detectors. So we didn't know that naade siya mga radioactive nga substance ang smoke detector. And then it looks gross, but actually gamma rays are well known to kill insects, larvae, and parasites such as trichina that causes trichinosis in pork. So, pwede siya mo-treat ana niya. No?